This is me, Ms. Schultz. So we're working on this. This is part 2 of this lesson. So on area and volume, the units area and volume. This lesson is just on area between two curves. So we're going to do it this style for now, so that you can hear me even better. So to continue this, this is the answer, -6 cosine of 3/2 plus 10.5. So let's go over the integral. The integral of sine is negative cosine, as I said. So -3 cosine of 1/2 x times by 2, because that's dividing by the derivative of the inside, which you can do when it's linear, plus 1/2 x squared. When you substitute in 3, it looks like this, minus a negative. And here's the thing, when you substitute in 0 to a trig function, you have to remember oftentimes it's not equal to 0. So that's the case in this, that's the case in this instance. So cosine of 0 is 1, so that makes a positive 6 times 1. The polynomial, of course, is 0. Okay, so here you go. Do this example all on your own, and then try to make it less, and then we'll group back with the answer. Okay. Alrighty, and we're back. Let's get it sketched out. So here's 3. Okay, 4 goes like this, minus x squared. Go down 1 over 1, and then you go over 2 down 4. We don't even need to know that. Okay, so the shaded region is here. So my integral is going to be from here to there, which is -1 to 1. Okay, my top function is 4 minus x squared. My bottom function is 3, minus 3. Hopefully you learned from the last time that it's much easier to simplify first and then integrate. Because I have 3 terms, and you know when you do definite integrals, you always substitute in twice. So 3 terms turns into 6 computations. So if you can get that down, the work goes down a lot. So 4 minus 3 is 1. So I'm going to just do -x squared plus 1, or you could do 1 minus x squared. So now I'm going to have to do 2 integrals, not 3, and do, with the substitutions, I'll have to do 4 things, not 4 computations, not 6. So it's much better. So -1/3 x cubed plus x all the way from -1 to 1. 1/3 times 1 plus 1. So that's -1/3 plus 1. So that's me plugging in a positive 1. -1/3 times -1. I'm just being really careful with my negatives here. Plus a -1. Okay. So I'll just combine these. I know normally I said to combine the integers and then the fractions, but this is so easy that I'll just do 2/3, 1, 2, 3 negatives. So this is going to be a -1/3. 1, 2 negatives, so it's going to be a plus 1. So that makes 1 1/3, or 4/3. So this is pretty beautiful. You just found the area. I mean, this is a big deal. You found the area underneath a random curve and divided by that, and yeah. Another way to do it is you could actually have just integrated 4 minus x squared, and then you would get this whole area, all of this, and then you subtract 6. 1, 2, 3, 4, 5, 6. You could do that too. Yep. All right, let's do this one. Find the area above the x-axis between the following two curves. Okay, so this is kind of tricky. This one, if we look at, okay, so we're gonna start this one together, and then you'll just finish it on your own. So if I look at this, in terms of top minus bottom, this keeps on going. So this, up until here, the square root of x is the only function involved, And then here, okay, you have 2 functions that are involved. So I need to create 2 different integrals. I'm going to integrate the square root of x from there to there, okay? And then I'm going to sum to it this area, which will be the square root of x minus 2, okay? So this is, if this is x minus 2, and this is going to be a 2. And then this is going to be a 4. Okay. So this will go from 0 to 2, this integral. You see that? 0 to 2. And then this integral is going to go from 2 to 4. But wait, I'm actually gonna really simplify this. So this is one way. This is one method, okay? But I'm gonna think geometrically a bit. So I assert that if you take the integral of the square root of x, okay? If you take the integral from 0 all the way to 4 of the square root of x dx, I should have put the dx there, okay? Then you get this whole thing, all of that. And you just need to subtract out the area of that triangle. Like, we don't need to integrate this linear function. Like, we can take the area of triangles pretty simply on our own. This is a 2 by 2, so that's 4 times a half. So the square would be 4 times by a half, because it's not square, it's triangle, so minus 2. So I'm gonna do it that way. But I wanted to show you this way because conceptually, like breaking this up into 2 integrals is something that I wanted to see. But geometrically, doing this geometrically is actually like more, you know, like whatever, it's quicker, you know, more efficient. So go ahead, do this on your own. Alrighty, and we're back. Okay, so let's do this. Integral from 0 to 4 of x to the 1/2 dx. So that's x to the 3/2. So remember our rewrite, integrate, and then we're gonna simplify. 2/3, 0 to 4. So I'm gonna rewrite. I'm always gonna have this minus 2. So I'm gonna rewrite this as a root first. 2/3 square root x cubed from 0 to 4 minus 2. 2/3 square root of 4 cubed minus a big 0 minus that 2. Again, that 2 is the area of that triangle. So the square root of 4, remember you don't have to cube first, although this wouldn't be a big deal. Well, I know off the top of my head, 4 cubed is 64, but maybe for you it would be kind of annoying. So the square root of 4 is 2. 2 cubed you do know off the top of your head, which is 8. So let's change this now to 6/3. So I have 16/3 minus 6/3, which is 10/3. Cool. Alrighty, so now we're gonna go over this next bit in class together, but I want you to do some APQs. Alrighty, so APQ 1, let R be the region, you're basically gonna do this on your own, in the first quadrant enclosed by the graph of y equals 2x and y equals x squared, as shown in the figure above. Find the area of R. So this, you might notice, is not a multiple choice question. This is part A of an open response question. Okay, so go ahead and do that. All right, let's come back together. I'm gonna do it just completely algebraically. So my top function is 2x, my bottom function is x squared. I'm going from 0 to 2. So another way, okay, is geometrically. So I can say the area underneath 2x, that's just a triangle. 2 times 4 is 8 is 4. So 4 minus the integral of from 0 to 2 of x squared dx. Okay, so I could do that too. But 2x isn't like a big deal to integrate, so it's x squared. Notice how when I plug in 2, I get 4. Like when I plug in 2 minus plug in 0, I get 4. Like that's the same. Minus a third x cubed from 0 to 2, you end up getting 4/3. All right, let's move on. Let's do APQ 2 now. All right, let R be the region bounded by the graphs of the square root of x and x over 2 shown in the figure above. Okay, so find the area of R. Oops, should have been showing you that the whole time. Find the area of R. So again, you have 2 different ways. It's kind of similar to the last one where I have like one curve and one line. So you have 2 different ways. You can do integral of top minus bottom and just use calc the whole time, or you can like use the fact that one of these is a triangle. By either way, go ahead. All right, and we're back. So the x value goes from 0 to 4. So x to the half, I'm just gonna rewrite it right now. I'm gonna do it actually geometrically halfway. So this is 4 times 2, so that's 8 times 2, so that's 4. Okay, so I'm gonna do that. Oh, it's just like the last problem. Interesting. From 0 to 4, 2/3 square root of x cubed from 0 to 4. So when I plug in 4, I get 8. So it's minus 4, minus 4. At the end of the day, you get 4/3. Huh, that's pretty familiar. Let's compare. So I'm finding the area of like this little sliver, right? Then let's compare that visually to the area of this sliver. Can you see how the areas would be the same? Yes, this is pretty interesting. So this is just the inverse of both of the functions before. This ended up being easier and nicer because polynomials are nicer than radicals to deal with, you know, like no fractional exponents. But yeah, so it makes sense that we get the same answer, okay? So we're gonna save that one. We're gonna save, let me see if there's any others that I want you to do. Cool, okay, we're gonna do the rest in class when you get back, and the next video picks up here at 8BQ9. Thanks, bye-bye.